So this is a function. It's an f of x. It's not like one of the common functions. It's not a parent function, but it's a function. And stuff happens to this graph when you do this stuff. Okay? The question is, how does that affect our graph? One way to do it is to make a table of the points that they give you. This is one way to do it. You don't have to do it this way. So if I make a table of the points that they give me, it would be x and then y, and it would be negative 4, 0, negative 2, 4, 0, 0, 2, negative 2, and then 4, 0. That's 5 points. Okay, so let's do this one right here. To do that one, I would add 3 to what? F of x is the same as y. And so I would add 3 to the y, right? So I would just go, let's see, x and then y. Let's see, it would be negative 4, negative 2, 0, 2, and 4. Add 3 to that, I get 3. Add 3 to that, I get 7, 3, 1, and then 3. Right? And then you just graph them. And that's your function. If you add 3 to it. If you add 3 to it, you would get this. And if you wanted to see it as a graph, you would plot them. See, negative 4 to 3 would be right there. Negative 2 to 7 is off my graph. That's 6, 7, so it's going to be up there. 0, 3 is going to be right there. And then 2, 1 is right. Oh, that's not 2, 1. 2, 1's right there. And then 4, 3. 4, 3 is right there. And so I connect the dots. So there's the function. So what happened to my function? It shifted up. Okay. Same thing with the other things. Okay, so this one right here, if I were to make a table for this one, what values am I changing on this one? Am I going to change the y values or the x values? The x values. So the y values stay the same, so they're still going to be 0, 4, 0, negative 2, and 0. How do my x values change, though? Now remember, when things happen to the x values, you got to think the opposite, the inverse. So if you're multiplying by 1/3, what's the inverse of multiplying by 1/3? Dividing by 1/3, or which is the same as multiplying by 3, right? So you would take all these x values, multiply them by 3. So this would be a negative 12, a negative 6, a 0, 6, negative, right? Yeah. No, just 6. And then 4 times 3 would be 12. Okay, and then I go to graph it. Let's see what happens. Negative 12, whoa, that's way off the graph. Oh, this one doesn't even fit on my graph. These are way off the x's, so I can't really see those.
No, negative 6 is just the edge of the graph.
Okay, we can do negative 6. Okay, negative 6 is at 4, so I go negative 6 to 4, which is right there. That's supposed to be this point, right? That's like this arc thing right here, remember? Okay, and then 0, 0, 6, negative 2, which is right there. And then we have a problem here. So our window's not big enough, but that's okay. We can kind of graph it to see what happens here. This goes like this, and then it's going to shoot down to there. We could only see this part of our graph. You guys see that?
Yeah.
We can only see that part of our graph in our window. We'd have to blow our window up in order to fit this graph. Does that make sense to you guys? Let's go ahead and do the other tables. I won't take the time to graph them this time. Okay, so for this one, so if I do this again for the orange one, if it says minus 3 in, like it's doing it to the x, which values am I going to change on all my points? Yeah, I would change the values of the x, so the values of the y would stay the same. So we have 0, 4, 0, negative 2, and 0. I'm copying the original numbers right here. So, well, how would I change the x values? If it says minus 3, what am I going to do? I'm going to add 3. Because remember, if you subtract 3 inside the function right here, it shifts to the right. Correct? You guys remember when we did that? Yes. So that means I'm going to add 3 to all these points right here. So it's going to be negative 1, 1, 3, 5, and then 4. And then if you graph it, you'll see it shifts this line right here, this line thing, 3 to the right. And then lastly, if this is negative, you just make all the x's negative. Okay? Yeah, they just switch signs. Does that make sense? Okay. And then graph it, because it looks neat, because you can see, oh look, it switched. Oh.
That was Patey.